Hello student, the topics which you have covered in 9th class is going to be discussed and extended in 11th. So the topics which you have covered in 9th, you remember motion? Can you recall something about it? When do you say that body is in motion? When do you say body is in in the state of rest? In the state of rest and in the state of motion. When do you say that? When you say motion, what is it? Motion means when you say that a body is in motion. But do you say always it is in absolute motion or it is a relative concept? Motion is a relative concept, right? Why so? Because I'm again telling you this thing. Let's have a look. Train is moving, but the person standing on the platform would be able to see that, okay, train is moving. But the person sitting inside the train would feel different way. The person sitting inside the train will feel differently. To that person, what will happen? The people standing at the platform would appear to be moving backward. So we can say that motion and rest are relative to each other. That is a relative concept, right? Everything in this universe is moving with respect to some other heavenly bodies. Can we say that? Earth, sun, if you look at it, we feel that, okay, we feel that right now we are standing, we are at rest, but we are not. Because we are standing on earth, that earth is rotating throughout. Okay? So you are aware of that. Earth is revolving around the sun. So this is very simple, rest and motion you have understood. Now what about the distance and displacement? Can you tell me what is the difference between the distance and displacement? If you have like this, O to A, a person travels from O to A and then A to B. So suppose this is 4 kilometer, this is 5 kilometer, this is 3 kilometer. What is the distance? What is the displacement? Distance, distance will be OA plus OA plus AB. Distance will be OA plus AB, right? So it is what? 7 kilometers. But when you say displacement would be what? OB, which is equal to OA square plus OA square plus AB square and square root of this. That is Pythagoras theorem, right? So this you need to find out. Using Pythagoras theorem, you can easily get this result that comes as 5 kilometers. This is very simple. Now let us move further. This one. Can you tell me what's the answer for this? When you have to find out velocity, what is it? What is the velocity? I think it is written. Because you know all this thing, basic stuff. So when you say speed equals distance by time. When you say velocity, what is it? Displacement by time. What's the displacement in this case? Distance and displacement. So distance would be, see, Kanha completes half of a circular track of radius 7 kilometers in 2 hours. So when you say half of a kilometer, half of the circular path, that means semicircular path. So A to B, the person has traveled. Here, name of the person is Kanha. Okay? So this is there. So if this is there, what's the distance? Now note this thing, length of arc equals radius into angle. This will help you understand things very easily. Suppose you have this circular path. This is radius. A particle, suppose a particle travels a distance from this to this. This is the distance traveled, right? Actual length of the path. So if you look at it, if two positions of a particle, two positions of the person or particle, whatever it is, makes an angle theta, so theta measured in angle, this angle theta is measured in radian, would be this. Theta equals angle equals what? Angle equals length of arc divided by radius. Can you acknowledge this thing? So considering this length of arc, that is AB, this S can be considered as R into theta, right? R into theta. When the person completes half semicircular path, what we can do? We can simply write S equals R into pi. Suppose the scenario is this. The person completes 3/4 of a circle. 3/4 of a circle. Then what's the distance traveled? R into 3 pi by 2. Can you tell me why this is going to happen? Can you tell me what is the distance traveled if the person completes 3/4 of a circle? Okay, so this you need to keep in mind, that pi radian equals 180 degree. When 1 degree equals pi by 180 radian, both are the units. If you want to convert degree into radian, you can convert it in this manner, and this will be the condition. So here we have A to B. This is A to B. The distance covered is S equals pi into R. So whatever values are there that you can put. Now displacement will be what? Displacement D will be equal to, what you need to do? You need to join the two positions. This is initial position and this is final position. This distance basically you need to calculate. So this is what? This is R plus this is R. So that means displacement will be 2 into R. What's the value? 2 into 7. That is 14 kilometers. 14 kilometers. And what about this? 22 by 7 into 7, that is 22 kilometers. So distance is 22 kilometers, displacement is 14 kilometers. Now the velocity that is asked in this, what is the velocity? Velocity V equals 14 by, what is the time? 2 hours. That means it is 7 kilometers per hour. 7 kilometers per hour is the velocity. If you need to find out the speed, what is the speed? Speed is distance upon time. That is 11 kilometers per hour, right? Speed will be what? Speed will be 11 kilometers. These things you must have done. It was just quick review of what you have done in 9th. Now let us move further and we will talk about something very interesting, and that is, just stay tuned, you will understand. Stay tuned. Look at this. If you can focus on the motion, try to notice the speed or velocity at the car is moving in a straight line. Its speed is changing, if you can see. Suppose it has traveled to this distance, from this to this distance. Suppose this is the total distance traveled. If I am supposed to find out the average velocity, V average, what I will do, I will see that okay, from the origin, initially it was at x1, it has started from point A, it has reached to point B, from A to B, and this B is at x2 position from here, and it takes time t. So for the entire time of journey, let's say this is 20 seconds, okay, 20 seconds, and I am willing to find out the average velocity. What I would do, I would do this thing, x2 minus x1 divided by whatever the total time taken is. So suppose x1 value is given as 10 meters and x2 value is given as 1000 meters. So what's the average velocity? Average velocity, can you tell me? Yeah, what's the answer? This is 1000 minus 10 divided by 20. What's the answer? This is 990 divided by 20. This gets cancelled. What's the answer? 49.5 meter per second. This is called average velocity. Now mind it, average velocity. But do you think that this same average velocity the car is maintaining? That means, okay, average velocity is this, but I am interested in finding out the velocity at this moment, at this moment, at this moment, at different moments. How can I find out the velocity at the given moment? Are you excited to know how to find it out? You know, velocity at a given instant is called instantaneous velocity. Instantaneous velocity. So one quick stuff that you need to keep in mind is very simple, that you think of not taking the entire time of journey. You are required to think of the journey completed in a very short duration. If you are able to break that, you can think that okay, in this very short duration, not the entire 20 seconds of journey, in this very short duration, what is the displacement? If that you will take, so average velocity, you are saying that delta x divided by delta t. Tell me if it is clear. No, it is not clear. Let me use another color. Yeah. So V average comes out to be what? Delta x by delta t. Alright, this is there. Now suppose I am making this delta t stuff very small. Delta t is very small. Then what will happen? Delta x by delta t. Delta t means what? Change in time, duration, like you have started from here and then the final moment where you have stopped your journey. So this can be given as very small displacement divided by a very small duration of time. So this can be called V average, V instantaneous. This V equals dx by dt. I will repeat it. What I am saying is, instead of taking the entire time of journey and considering the net displacement, I am interested in finding out the velocity at a given moment. For that I will break this entire time of journey in very small segments, very tiny duration. In that tiny duration, this delta t approaching 0, that very tiny duration, in that tiny duration, what's the speed that we are interested in finding out? So in that tiny duration, the speed or velocity will be this. Understood? Very small displacement, very small time duration. Got it? You are simply making that time duration very, very small. So it's obvious that for that very small duration, the displacement will be small, right? Very small displacement. So look at it. Now if you would look into this, you will be able to understand. Model your thinking according to this graph for this particular situation, instantaneous velocity. Can you see here this distance and time graph? In this distance and time graph, you would see that at every point you have got same slope. Here slope appears to be like this. Here the slope appears to be like this. Here the slope is like this. Here the slope is like this. So do you see that at every point the slope is different? So if you are willing to find out velocity, so you would do one thing, that you will find the slope. This is delta x, this is delta t. If you make this thing tiny, then what will happen? It will be dx by dt. The velocity will be what? Dx by dt. You can't take this slope for this entire time of duration, time of journey. Otherwise what will happen? You will end up getting the average velocity, not the instantaneous velocity, because here you are seeing that every moment the slope is different. When you say every moment the slope is different, every moment velocity is different. So this you are required to understand. Now question arises, how to use this tool? So for this I would like you to move further and see this thing. Average instantaneous velocity, this you have understood, right? Now think of this very simple thing. Suppose you have a scenario, you have a condition where position of a particle changes according to, as per this equation, as per the equation, x equals t raised to power 3. Okay, focus on this. And now you want to get this dx by dt. This is very simple. Change in position with respect to time. Change in position with respect to time. This is velocity, right? So v equals this. So change in position. What's the basic concept that you are required to use? See, you will simply do this thing, that this is the exponent 3 here, put the exponent, then multiply it with t raised to power the exponent, earlier exponent, minus 1. Just this thing you need to do. This comes out to be 3t square. So this is velocity. Now if you will put the value, different value of t, you will be able to get the instantaneous velocity. Velocity at a given instant. So this is the formula that you are required. This is the general formula. If you would look into this, I have simply used this formula. Now if you have some constant also there in the multiplication factor, as a multiplication factor, if there is some constant multiplied with this, then what you will do, whatever you have found here, multiply with that constant. So I will tell you this thing. Let us have a question. Yeah, this is the question. Can you help me get the answer? See, v equals dx by dt. The basic idea is t raised to power 3, that means 3 into t raised to power 3 minus 1, that comes out to be 3t square, right? 3t square. This constant was multiplied with this. What you will do, you will multiply this thing with the constant given in this expression. So just get it. This is 9t square. This is the expression. Now the given instant is t equals 2 seconds. So what you will do? Velocity at t equals 2 seconds will be 9 into what? 2 raised to power 2. Why so? In place of t, I have substituted this value. I have done it, and then it comes out to be 36 meters per second. Understood? So this is the exciting thing. when you are required to find out average velocity, what you will do, you will take the entire time of journey, net displacement and entire time of journey. When you will require to find out instantaneous velocity, what you will do, you will see the expression, how the position is changes with respect to time. With this expression, you will simply do dx by dt, and you know the basic stuff. Then you will calculate this and then put the value of t here to get the instantaneous velocity. So from my side, this is it. I hope you have enjoyed the session. And if you have to talk to anything about the classes and all, you can call and you will get all the informations, right? Okay. Welcome. Bye-bye.